So let's go ahead and wrap this lesson up by talking about some word problems. Now with word problems, we know that the hardest part of a word problem is the setup. How do I take the words and turn it into a math problem? So once we get to the point that there's a quadratic equation to solve, I'm actually going to stop and move on to the next word problem. Just in the interest of time, this video is already running long and I care about your time. And you can go ahead and solve it just like the other quadratic equations we've solved. So let's look at this word problem. Alex walks along a sidewalk for X feet. He then makes a 90-degree turn and walks 10 feet further than before, so X plus 10. But if he would have just cut across the lawn, then it would have been 40 feet. How much distance would be saved by cutting across the lawn? So this is actually a really tricky problem. So if we draw a picture, it's going to definitely help us. But there's still a nice trick to it. So Alex walked X feet, made a 90-degree turn, and walked X plus 10 feet. But if he would have just cut across the lawn in the first place, so straight from point A to point B, he would have gone 40 feet. Now, what I want to look at, though, is how to answer the question, because the answer to this question is not the same thing as solving for x. X equals doesn't answer the question that was actually asked of us, and that's why I want to go over an example like this. Because notice that the question is actually asking, how much distance would be saved by cutting across the lawn? So if I want to know how much distance is saved, then really what I'm looking for is to take the long ways distance minus the shortcut or the short way. So if I just subtract those two values, that's going to get me the distance saved. Well, the long way of walking along the sidewalk was to walk x feet followed by x plus 10 feet. The short way was 40 feet. So if I combine like terms here, the answer to my question is actually 2x minus 30, if I only knew what x was. Where if x was, let's say, 20 feet, then my final answer would be that I saved 10 feet. Because if x is 20, 20 times 2 is 40, 40 minus 30 is 10. So I know that this is the actual answer to my question, but I need to figure out what x is. To solve for x, I can take that right triangle over there and use the Pythagorean theorem, where I have x squared plus x plus 10 squared equals 40 squared. So that I have x squared plus x squared plus 20x plus 100, once I square that out, equals 1600. Or 2x squared plus 20x minus 1500 equals 0. At this point, I could use the quadratic formula until I get two answers. One of those answers is going to be stupid because it's going to be negative or something dumb. The other one's going to be reasonable. I then plug that reasonable number in until I come down to figure out how many feet were saved. And that's the basic approach to that particular problem. You just got to use the quadratic formula on that quadratic equation to figure out what x is. But in the interest of time, I want to look at another example. This one tells us a ball is thrown downward from the top of a 180-foot building with an initial velocity of 20 feet per second. The height of the ball, h, after t seconds is given by the equation blah. So all that information that we started with in the first part isn't necessary because it just explained why that equation works. Now that equation has two variables in it, h and t. H is the height of the ball, t is the time in seconds. We're being asked how long after the ball is thrown will it be 50 feet from the ground. That 50 is going to go into either t or h. And oftentimes on problems like this, just look at the units and it's going to tell you exactly what to do. 50 feet, is that a height or is that a time? Well, of course, it's a height. So we're going to plug 50 in for h. Now, the other thing that you'll see in problems like this that I want to go ahead and just talk about real quick in this video is sometimes you're going to be asked on a problem like this, how long until the ball hits the ground? So it doesn't explicitly tell you how high off the ground the ball is, but you have to realize then that if the ball hit the ground, its height is 0. So if you're looking at how long it takes before the ball hits the ground, you're looking for a height of 0. So onto this problem, we can't quite solve it yet because this isn't in the form ax squared plus bx plus c equals 0. We need to get a 0 on one side. So I'm going to move everything to the left-hand side to get 16t squared plus 20t, and I'm going to subtract the 180 on over to get minus 130 equals 0. At which point we use the quadratic formula, we use our calculator, we go from there. Now, I also want to talk about using your calculator. So once we have this, let's go ahead and do this one. I'm not going to use the trick because I'm going to use the calculator anyhow. So I'm going to have the opposite of b plus or minus the square root of b squared minus 4 times a times c. I'm going to use my little trick again of negative 4 times negative 130, just make them both positive, all over 2 times 16. Now there's a lot of parentheses going on here, so you might want to jot this down of how to put this into your calculator. Now for those of you that have the TI-30XS multi-view, you want to use the fraction button in your calculator. Then you can just go ahead and put everything up top together, everything in the bottom together, and it's a piece of cake. But for those that don't have the multi-view calculator, what's going to be important here as you put this into the calculator is that you need to have parentheses around your entire top, to have parentheses negative 20. Now you can't do plus minus in the calculator, we've got to start with plus. Now when you hit square root, you also need a parenthesis to say all of this is in the parenthesis together, or under the square root rather. So 20 squared plus 4 times 16 times 130. Now the first end parenthesis ends the square root. The next end parenthesis ends the entire top. Now when you do divide by, you need parentheses for your bottom too, to say all of this is in the bottom together. Now you're going to go ahead and retype all of this and just change the plus to a minus. This can be done using the entry button in the calculator, which is second, then enter. Or in some calculators, you can just arrow up to the previous entry and hit enter on it, and it copy and pastes it. But make sure to write down how you're supposed to type that in, that you need parentheses around your entire top, parentheses around the stuff inside the radical, and parentheses around your entire bottom.